Today we're going to be talking about circles. Yesterday we talked about parabolas. We knew that something was a parabola because only one variable was squared. Today, when we talk about circles, you know that you're dealing with a circle if you have three things that happen. First of all, you have x squared and y squared. Both variables are squared. They'll also have the same coefficients on x squared and y squared. The last characteristic that allows you to know that it's a circle is that between those x squared and y squared, there's going to be addition. Those three characteristics will be helpful to remember as we keep learning about other conic sections. Key thing you need to know about a circle, right here in the center, is the center. We give the center the variables h and k, and then the other piece of a circle that you need to be familiar with is the distance from the center to the outside of the circle, which we call the radius. We label that with r. One way that you can be given the equation of a circle is in standard form. Standard form is the most helpful form of a circle because you can easily pick out the center and the radius. In standard form, the circle looks like this. In one set of parentheses, you'll have x minus h raised to the second power plus y minus k raised to the second power is equal to r raised to the second power. Now, picking apart some key parts of that equation, their center is h and k. Notice how in this equation, both the h and the k have a minus sign in front of them. So when you take the h and the k out of the equation, you'll need to change the sign of both of them. The radius, the distance from the center of the circle to the outside of the circle, is r. To go from r squared to r, you'll simply take the square root. So we're going to break this apart into three pieces here. We're going to find out how to write the equation of a circle when we're given different pieces. We're going to draw a circle when we're given the equation. And then last, we're going to write an equation when we're given different pieces of the circle. So starting out with most basic, if we're given the center and the radius, we would label our center h and k. H and k are going to go right back into the equation in those two locations. We know that the radius is 6, so I'm going to label that with a little r. Start out, we have x minus our h. Since our h is negative 10, we're going to actually add 10, square it, plus y minus our k value, the y value of the vertex, which is 1, squared, equals, and then when we plug this back in, this radius back into the equation, we square it. 6 squared, or we can write that as 36. So that's the equation of a circle with a center at negative 10, 1, with a radius of 6. Let's try out B over here. Again, we'll label the center H, K. The radius is R. We'll plug in those H and K values in the places that we see them right up here. So we have X minus negative 14 minus a negative makes that plus 14 squared, plus y minus negative 9 squared. Since it's minus negative 9, that changes it to plus 9 squared, equals our radius squared, which you can write as 2 squared, or you can simply write as 4. Take a moment and give C a shot. Again, you would want to label your center as H and K. Your radius is your R value. You should have X minus 5 raised to the second power plus Y minus 0 raised to the second power equals the square root of 3 raised to the second power. That is all perfectly fine, but another way that you'd write that, can't simplify x minus 5 squared, we would leave it just like that. Since y has 0 subtracted from it, we can just write it as y squared equals, and when you square a radical, it gets rid of that radical, or square root of 3 times square root of 3 is square root of 9, which is just simply 3. Again, take a moment and try out D. We have our center here is HK, our radius is R. Should have x minus 6 squared times the quantity of y plus 5 squared equals 2.5 squared, which you can also write as 6.25. Notice how when I plug the h and the k back into the equation, they have opposite signs of the actual coordinates. That is how you write the equation of a circle when you're given the center and the radius. Now we're going to go kind of in reverse. We're going to be given the equation of a circle, and we're going to find the center and the radius, and then we're going to graph it on a coordinate plane. We're given the equation of a circle right up there. To find the center, it's an ordered pair. You need an x part and a y part. The x part's going to be inside the parentheses with the x. The y part's going to be inside the parentheses with the y, but make sure that you change the signs when you take them out of the equation. So your center here would be -1, -1. Your radius is in the equation, but remember it's in the equation as r squared. So to find the radius, we're going to take the square root of that constant on the other side, and we're only going to take the positive root. So the square root of 16, we get 4. When we're actually taking that and graphing it, you would start at your center, -1, -1. Your radius is the distance up, down, left, and right that you can travel to get from your center to the outside of the circle. So we would go up 4, 1, 2, 3, 4, make a point. Right 4, down 4, and left 4. Connect those and make sure that it's as round as possible. We don't go diagonally 4 or any other direction besides up, down, left, and right because those aren't exact units of 4. I'll take a moment and try out the one to the right. On this one, you should have gone inside with the x to find the x value of the center, which is +2. The y value of the center is +1. Notice how I changed the signs when I took them out of the equation. The radius is not 9. This is the radius squared. So when you take it out of the equation, you take the square root. We only take the positive root, and we get 3. If you have not already, take a moment and graph that circle on the coordinate plane. Should start at your center of 2, 1, right 2, up 1. Your radius is 3, so count up 3, right 3, down 3, and left 3. Connect those points to create your circle. In our last portion, we are going to be given some other information about the circle, and our goal is going to be to write the equation of the circle. So we're going to have to take some extra steps to get there because we're not going to be given point blank the center and the radius. So we'll do some extra work to make that happen. Just keep in mind that the equation of a circle is x minus h squared plus y minus k squared equals r squared. H and k are the center, r is the radius, and x and y typically just stay as x and y unless we're given some other point on the circle. If we are given some other point on the circle, we can plug that point in for x and for y. So let's see what we've got here. We're given that the center is 4, 6. Since we're given the center, we would label that with our h and our k. We're given another point on the outside of the circle is 6, 10. We're going to label that with x and y. We're going to plug in all 4 of those variables into the equation, an x, h, y, and k spot, and that will allow us to find our radius so that we can go back and then write the equation of the circle. So we have x, immediately run into x, we're going to substitute 6 in for that value, minus our h value, which is 4. We're going to close our parentheses and square it, plus y, which we have here is 10, minus our k, which is 6. Don't forget to close the parentheses and square it, is equal to, we don't know what our radius is, but it's squared. Follow your order of operations, work inside with your parentheses. Then solve with your exponents. Then finally add, and we get 20 equals r squared. Since we're asked to write the equation of the circle, you'll notice that back in the equation of a circle, we plug in r squared. We now have what r squared is, so you could take the square root and actually find that the radius is the square root of 20, but since we're plugging r squared right back into the equation, I'm just going to stop right there in terms of solving for r. We now know what r squared is. We also know what our center is, so we can take those, plug in the h and the k, plug in the r squared, and we have the equation of the circle. So finally, we would have x minus our h value is 4 squared plus y minus our k value, which is 6 squared, equals our radius squared, which is 20. That would be the equation of a circle that goes through, that has a center of 4, 6, and would pass through the point 6, 10. Take a moment and try out example B. Same deal on this guy, except you have a different center and a different point on the circle. Should have plugged in your x, your h, your y, your k, solved using your order of operations. Once you find that r squared is 74, you can take your center up here, your r squared, plug them in to write your equation of a circle in standard form. You did it.